Hello, everyone. My name is Oleg Grenrus, and I will talk to you today about OO as object-oriented vs FPS functional programming. There's already talks today which introduced functional programming. Who is familiar with idea of functional programming? Okay, so about half of you. And I don't see them as different beasts, because my goal as software developer is to make good software. And then I use some ideas of what good software looks like, and then it turns out that if I choose object-oriented language or functional programming language, then in the end I will use similar concepts. They just in different communities, like object-oriented community and functional programming communities, they are named differently, but the core ideas behind are the same to make software. I don't know, maintainable, readable, testable, you name it. A bit about me. I'm a runner or co-organizer of Haskell Helsinki user group. So it's Helsinki. And I work for Futurize, which is a IT consultancy. So I might be already biased, so I would prefer Haskell to say some other language, but you cannot always choose. So, but if you can, choose Haskell, and don't choose Scala. That's my opinion. Okay, the outline of the talk. I'll first talk about a bit random concepts, and then I go through solid principles and iterator pattern, which are kind of object-oriented world, and then functional composition, which is functional programming, and then expression problem, which is a problem coined in the functional community, but it's relevant to all languages. It's actually one problem you want to solve to make your system nice in different ways, but it's a difficult problem, so it will be at the end. So it's like round one in this fight is just introduction. So what we do when we write complex computer systems, and to make them somehow manageable, we layer abstractions and many layers. And in software engineering, we use design patterns to some what design patterns are, something how we would build the software. So they are kind of good things which we already know and reuse them. So one way to say it is that design patterns are reusable abstractions. So as already seen in the outline, for example, iterator pattern is the iterator there is an abstraction which we use, and it's I hope that we all agree that it's usable where it's applicable. So a bit about abstractions. The basic abstraction is data abstraction. For example, we could talk about two doubles, but not usually, but sometimes we want to talk them as a whole, as a point. And it's different if we just pass two doubles to some method or we give it a point. So we raise the layer, raise the abstraction, we talk about points and not about just pairs of doubles. Does it make sense? Okay, data abstraction is easy. It looks the same in every language. Like previous session, that was about Lua. There they use tables. They just named fields, and that's your data abstraction. And you have structs in every language. In Scala, it's called case class, and in C, is struct, and every language should have some kind of data abstraction, except assembly. There you don't have anything. Then there you have to remember all the offsets yourself. So there is no abstraction at all. But we don't write assembly that much. But the interesting abstraction is a abstraction of control. So we want to work with data, but abstract that how we work with that. So if we take the point as an example, there's different things we could do with that. But for example, okay, point is a bad example. Maybe I just show this one. Say we have cat and dog, and they both have names. On the left-hand side, there's a C++, and on the right-hand side is Haskell. So C++ is very object-oriented, and Haskell is very functional programming. Hopefully, the syntax won't be the problem for you, at least for this Haskell, and I guess the C++ syntax is familiar. So both cat and dog has a name. So in C++, we would have a method there, which is name on both. And in Haskell, we will have two functions, cat name and dog name. They're named differently because we have to have different names. But if we put them in different modules, then they could be the same name as well. But so naming is not the problem. The problem is when we want to work with something which has a name, how we would do that. So we don't care if it's a cat or it's a dog. We want only to know the pet's name. So in object-oriented world, we will create a parent class or interface or trait or whatever you call it, and that one will have a method name. And then we inherit that named class to make a cat and a dog. In Haskell, what we do for this kind of abstraction, we say that there's a things which has a name, and then we tell that class has a name A, so A has a name, and then we give different instances. So that if you think about it a bit harder, then it's exactly the same idea. Just on the only difference that in C++ you have to decide it up front. So when you create a class, you select which interfaces it implements. Same with Java. But with this type class approach, you could implement them afterwards. So I didn't have to change my cat or dog. I just told compiler how to use name with cat and dog. For me, it's more convenient, but yeah, it works the same way. So the compiler just knows which name, when I say name, which one to pick. An important thing about C++ that if the method is not virtual, it will be selected on compile time already. I'm not sure who is familiar with C++, like know it well. Only few of you. So who is familiar with Java? Okay, so in Java, the method dispatch is always virtual. So if I give a named thing, so if I have a function or method which takes named, and I call name on it, it will select the right method on the either the cat name or dog name. But C++ will tell, if it's not virtual, that you are calling name on an abstract class, because it will try to call this method which is not implemented. So there's the difference. Do you want to make a static dispatch or dynamic dispatch? But I'm not going there, but sometimes you really want to make everything statically, so you don't look up the kind of class information at runtime anymore. So you want to do everything statically, but sometimes it's very hard. Okay, and one point is that control abstractions are more powerful than data abstractions. Because, for example, in Haskell, we could say that Booleans are functions of type functions which take two parameters of the same type and return the value of the same type. And there's only two options how to implement this function. Either the true, which will return your first argument, or false, which will return the second one. And there's no other way to make this kind of function without making some side effects or looking up what type that is. So it's called church encoding, and kind of nice trick. So at the essence, if your language only has functions, you can still do everything. But the same is possible with a C++. So if I have a parent class Boolean, which has only one operator, which also takes two arguments, and then I could have a subclass true, which will return the first argument. And as you can see, there's no fields in this class. So like there's nothing except classes and methods. There are no data as such. And this is kind of cool, but so the point here is that classes is an abstraction mechanism in object-oriented languages, and the functions are in functional programming. But for example, here my class has only one method, so it's essentially a function, which that function itself. In older C++, I don't have anonymous functions, so I have to use kind of this encoding to do similar stuff. Okay, and there was talk by Scott. I don't know how to pronounce his last name, and he started with kind of this slide. So we have many patterns in the object-oriented community, and they are more or less well understood, and we use them, and then you kind of have a problem, and then you just look up the design patterns book, and then you select the right one, and then you're done. And on the functional programming side, we have only functions, so kind of no patterns. That's of course not true. A friend made a kind of answer to that. So we have kind of patterns and principles in functional programming as well, but the opposite on object-oriented side is objects or classes. And what I will show you next is that the difference is actually naming. So you could see that both object-oriented principles and patterns are good in functional programming on functional programs, and vice versa. So it's not, there's no strict division. So those principles are more general than just OO. Actually, at one point I saw that should I make an example in Scala, so you can have because Scala you can do very object-oriented way and very functional programming way. Then I just decided to use different languages, so it will be more obvious that they're different. Okay, so the second round is a solid. Who is familiar with solid principles? You should look up them. They are good principles. So there's 5 principles, and it's easy to remember because it's solid. So the first one is single responsibility principle. For object-oriented programming, it says that every class should have only one single responsibility. And the same you could say for functional programming. You just change the class with function, or in Haskell, type class, which is also class. So the same principle. Don't make kind of stuff which do 2 or 3 things. Make 2 things which both do only one thing. So that's clear, I guess. Nod if you agree. Okay. So open-close principle is it's I guess the most difficult one from these 5. It kind of states that we should try to make our software so we cannot change the core, but we can extend it. And that's kind of very difficult to give an example. That expression problem I'll go at the end is is kind of example of that. So it's only at the end. But even if all those quotes are from Wikipedia, and it says classes, modules, functions, so it doesn't. If you just hide the object-oriented programming, so it's object-oriented, then it's valid still. It could be any programming. Liskow's substitution principle is one hard as well. Unluckily, this picture doesn't show as well. It's a kind of class hierarchy in length library for Haskell, and there is different things. For example, if I remember right, that this one is length and this one is traversal, and you can always use length as traversal, and that's what Liskow's substitution principle says. So if you have something down in your hierarchy, you could use it as an object of higher class. And that's a good mental exercise to think in which way you should inherit square from rectangle. Which one should be the superclass? Or square? Think about it. It changes when you allow mutation. Because for square, if you say set width, but then the height changes, and rectangle doesn't behave that way. So rectangle cannot be a superclass of square if you allow mutation. Yeah. So if you will do Scala, then there's a covariance and contravariance terms, and they're related to this one. So if you allow mutation, then things get much more difficult. But you don't need to mutate in object-oriented world either. So it's not mandatory in object-oriented programming. Oops. Okay, the 4th principle is interface segregation. So you just have to make small interfaces. So not interfaces with tens of functions, but like with as few as possible. Haskell has many classes which has only one method. So because we are interested only in that particular functionality. And that's probably one reason why people are scared of, I don't know, Haskell or functional side of Scala, because there's very many concepts, but they are all very small. So it's kind of quality and quantity compromise. You have either you can bake everything into single and big interface and try to understand that, or then you split it into simple, smaller things and understand them one by one, or as you need. And that smaller one is proven to be better. And the last one is a dependency inversion principle. So that says that we should always program against the interface. And interface doesn't mean interface as in Java. It's a contract which we program against. So, and in different languages, we encode contracts a bit differently. In Haskell, there's a contract which says monad state. So it's a monad in which I can get state and then I can put it back, some different states. So I can have locally stateful computations. And then in my client code on top, I can just use this fact that I have access to the state, which is my state. And I don't need to care how it's implemented. And here we can see one way to implement it, but it's very many. It depends on which concrete instance of this monad state I pick at the end. I am free to do it separately from my implementation. You do that in object-oriented programming, you do that in functional programming. I hope you do. So this was about solid. Do you have questions at this point? Okay. The third round is about iterator pattern. Who is familiar with that one? Okay, the same hands raised all the time. So iterator pattern is a thing to deal with containers generically. Say we could have a container, a list, or we can have a vector or set or something else, and we are only interested in its contents. We want to go through all elements and do something. How we do that? So we don't care which container we have. In object-oriented language, we will use iterator pattern. So that container will give us an iterator, which is iterator is the interface which could go forward and then access elements it kind of points to. And then do things with that element. And we might change the value there or not, or just accumulate the values. Or we can do almost all of our container access with iterator pattern. For example, which language I would pick? In Python, there's generators, which are kind of another word for that thing. So you could have a thing which you can for loop over, but it will use an iterator under the hood, which you could implement yourself. So that you could reuse the syntax of the language with your data. Okay. But there's actually a paper which says that the Haskell traverse operator, you probably cannot read it, implements the very same idea. It looks a bit different. And it looks much more scary than iterator. But here, T is a container, and you don't need to care about F, but if you care, that it's a kind of a context. So we can do stuff with a value. So we could print it, or we could have a stateful computation, or like there are many applicatives. And here, the traversal is that, or the for loop is baked into this one. So I give a function which I will do on every element. Then I give a container, and then at the end they will return me container with that function applied to every element. So exactly as a for loop with iterator, but that is how it looks in Haskell. So I would just use the anonymous function. Yes, question. No.
Why don't you write containers like you write
Uh, well, it says traversable T. Then I could say traversable again, but I will repeat myself. Well, I guess one good reason, I don't know if it's true, is to fit stuff on the slides. But because the better answer is that the concepts like traversable applicatives are so abstract that the only word you could say is applicative for that, because traversable could not be a container. It's just a container in the sense it might be not the list. It's I could have a traversable for I don't know. For example, for cat, and the traversable will return its name. So I don't know, you can understand the cat as a container which has a value name, but then when you use that function on your cat and then substitute cat with container, then it feels kind of weird. But if it's just abstract traversable, then it's abstract traversable, that's okay. It's
I by myself have no experience in Haskell, and I just know that in Java programming pay attention on the readability and variable names, method names, and I just wanted to know if Haskell code always looks like this.
No. This is kind of the most abstract thing you see in Haskell. But when I have a, I don't know, web service, and I want to make a HTTP request, and it uses manager to handle HTTP connections, I say new manager TLS default settings. So it's whole words and long ones. And it feels like full buffer. But for that thing, for concrete things, we use concrete words. But those are abstract. So it's no good name. That's a problem. Hopefully I answered. And this one, as I told, talks about containers. So that's container of some elements. But it doesn't have to be. It could be something very concrete. For example, text. You can think about it as a container of characters, but it could be implemented in many different ways, which is not directly a container. It's contiguous space of memory, and you cannot access it randomly, and then, or cannot have other elements there except the char. So you have only text here, and then you will have char here and char here, and another text here. But I was lazy and didn't wrote out the example. I could come back to that if you have time at the end. A functional composition is the pattern we use in functional programming. So everything is somehow composition, and most likely we will compose functions. So, for example, a decorator pattern, if that's thing where we compose stuff. So, for example, let's say we have coffee, and then we have a coffee class, and then we want to have another class for coffee with milk. So not to repeat ourselves, we make a decorator with milk, which is always a coffee and takes coffee as an argument. So we start with coffee and add milk. And if we are in cafeteria, it costs us a bit more. But in Haskell, we have a structure coffee, and it has field cost, which is kind of a method of 0 arguments. And what we do, we change the cost in the coffee by taking old cost and adding 50 cents if we in Europe. And there's weird symbols, but you get used to them. But otherwise, it's the same idea. But because my method of abstraction is functions and not classes, so I don't create new class, I create new function. And then I change my actual data representation to be new one. Another pattern is factory pattern. We have class which could be created in many ways. And then we have a third-party algorithm which we give that how to create our objects. And it depends on the use, we might want to create them differently. What we will do in object-oriented language, we will create a new object with some new interface, which is a factory, and many subclasses with one method, create or make new, which will create our object. In Haskell, we will just use single function, because that's what the factory interface actually is. It's just encapsulating that one method. We don't need the class. We have that functions on head already. So, for example, if we have, if we give forward how to want our coffee, we could just give coffee, or we can give coffee with milk. And here I use my previous decorator with already defined factory. So they compose nicely. And you can do, and you probably do that in object-oriented languages. You just don't understand or see that it's just functional composition which you do, because there's so much more syntax around that. Now it's a good point to challenge me, because the next thing is the expression problem. No questions. Okay, the expression problem. Who is familiar with that? No one. Okay. Let's imagine we have we make a small expression evaluation language, like the calculator. And we have literals there, numbers, and we can add and multiply them. And those will form our expressions. And we could do many things with them, or want to do many things. We can evaluate it to the final value. We could view them, like print for user, or we could simplify, like do constant folding if we, for example, have variables there. And the problem is that we might want to add more operations, like exponentials or variables I mentioned, or we want to expand another way to add new functions on the expressions. For example, we could compile them to native code. And the expression problem states how to make this so we don't need to touch which was already done. So we can, for example, add one row without touching anything, or add one column without touching anything, like expand naturally. So we could have a core thing in a library which we cannot change, but we can expand it in both ways. So this is kind of open-close principle. This one is closed, but we want to expand it in two directions. If we expand only one one direction, it's easy. We use inheritance in object-oriented languages. So we just, if we want to add one node and we have a fixed set of operations, we just implement all of them for new node type. Like the node interface has all those operations. Easy, one way easy. If you want to do other way around, then we'll have a operation interface and it will work with a constant set of operations or nodes. But what you will do if you want to go like both ways? It's a thought exercise for you. So we would like to write this. So we would give an operation and node, and it will do that thing for us. And then we could implement them in any order, and then the compiler will pick them. But you don't have that in Java, you don't have that in C++, you don't have that in any statically typed language I'm aware of. You have that in Python, you can simulate it in Lua, but because then you kind of cheat and use runtime type information. But how to do that kind of statically? And that's a problem which actually doesn't have a good solution in Haskell either. So it's a difficult problem, and OO doesn't have a solution, FP doesn't have a solution. Or both have solutions, but they are very, very hairy, and you cannot fit them on one slide. So it's kind of, if someone comes with a new paradigm which could solve that expression problem elegantly, then it will be much better. But kind of in this round, it's tie again. So none is better here either. So I hope that gave you a bit of thoughts. So, and you won't be scared about functional programming, because you can still use all these patterns and principles you learned. You have to learn only a little bit, like the new names of them or how they look like in new language. But otherwise, the core principles are general. Thank you. I guess we have a few minutes for questions. Yes?
Tell about Haskell in real life. How is it used? Which companies are using it for what services? What can you do with it?
At my company.
How enterprise ready is it?
Sorry?
How enterprise ready is it? In production, is it? How well can it be used?
So the question was how production ready is Haskell. It's very production ready.
Yeah, but what can you do with it if you compare it to Java? Java is used everywhere, and Haskell, what's the use case of Haskell?
Haskell is general programming language. You can do anything you want. The problem is libraries. And for example, web services, one good example where you have very good libraries. You can do your REST APIs with Haskell in one screen. That's the promise Node.js gives you, but Haskell delivers it like 100 times faster in production. That's one example. And I cannot comment on other uses because I don't use it. I don't have a domain need for other users. If you Google, there is a Reddit thread about which domains are good covered, which domains are well covered in terms of libraries and which are not. So web services are good, for example, and image processing is, I guess, bad one. You don't have good libraries. And the reason is because you have good libraries in other languages. For example, OpenCV, so you just bind to them and use Haskell as a glue language then. But it's not pure Haskell implementation anymore, so. Yes. One more? Yes.
As you mentioned, you can easily do REST APIs.
Yeah.
Have you had experience with those basically parsing out different types?
Let's see.
Any preparation?
The problem with Haskell is as ready, for example, as Scala. I don't know if it's a good comparison. If what I face myself is that it's much harder to write Haskell code for consuming APIs because their documentation is so poor. But as a Haskell programmer, you ask those questions. For example, is this file optional? You really care about that, and then you're given one example, and then you're unsure. And that's kind of the problem. So you face those questions up front, and then you ask them from API developers, are those optional? So the first week, 2 days, you bomb them with the questions, and after that it's smooth ride. But if you would go with, I don't know, Node.js or Python, and you don't validate your input as precisely, then you just face that problem later. So it's a bit amortized, but I don't know. It might result in a critical bug in your software. So if it's important to you or not, that... Did I answer your question? Yeah. Okay, thanks you again.